Hello friends. So today in this video we will be seeing with the next algorithm, that is priority scheduling algorithm, which is non-preemptive in nature and preemptive in nature. So firstly we will be seeing with the non-preemptive priority scheduling. Okay. So as we have seen in the previous examples and previous problems, okay, the given data will be your process ID, arrival time and burst time is a given data for you. Okay. So here in priority scheduling, this works on also the priorities given for you. Okay. So if it is asked with the priority scheduling, they will be definitely giving you the priority ID. What is the priority of each process ID? What is the arrival time? What is the burst time? Burst time is sometimes also they can give it as a execution time of that process. Okay, so don't be confused with what is burst time and what is execution time. It is one and the same. Okay, so now if this is the given data for you, so now let us see how to solve it. As you know that from the given data, the first thing what we have to do is what? We have to draw the giant chart, right? So how to draw the giant chart for the priority scheduling, let us see that. Okay, so looking at this arrival time, the first process which is arriving is what? At the 0 time location, it is process ID 1. So what is the burst time of that? It is 3. Okay, but it will be not completely executed or partially executed. That totally depends on whether we are going with preemptive or non-preemptive nature. So now if you see this priority scheduling, we are solving the problem using non-preemptive nature. So at the 0th time location, process ID, when it starts executing, okay, so it will be not preempted. So definitely process P1, if it starts at 0, and it will completely execute and then move for the next process. So as you have seen, process P1 starts at the 0th time unit and it will be ending at the 3rd time unit. But when this was processed, which are the processes which are in queue now? Right, if you see here, the arrival time of process number P2 is what? 2, and process number P3 is what? 1. So can you just understand that process number P2 and process number P3 are existing already in your ready queue. Okay, which is the first process, that is process number P3, and after that which came? Process number P2 came into this queue. So immediately when P1 is completed, now which will be taken? It is P3. Why? Because that is the process which is coming at first. Okay, and that is first unit time. After process P3, P2 has been arrived. So definitely P3 will be given the second chance. So what is the process P3's burst time? The process P3's burst time is 4. That means 3 plus 4 is 7. It will be executing till 7 unit of time. So during this process, 7 unit of time, that means P3 has been exited from the queue. What is remaining in the queue now? Only P2. Okay. But when the process of 3 to 7, that is when the time unit is traveling from 3 to 7 during the execution of P3, you can see here 4, 6, 5, 7. These are the processes, process 4, process 5, process 6, and process 7 all have arrived over here. Okay, so which is the first process which has been arrived? That is after P2, we can see in the queue is P4, and after that we can find after 4 which is arriving, P6 is arrived, correct? And after that, which has been arrived, after P6, you can see P5 has been arrived, P5, and after that, you can see that the last one, that is at the 7th unit of time, we can see P7. So this is the order in which the processes will be executing. So after P3, which one will be executed now? You can see here, okay, according to this arrival time, which one will be executed? P3 has been executed now successfully. And after that, at the 3rd unit of time, if you can see this, okay, if you can see this at the 3rd unit time, all this has been arrived. But it is not only that with this arrival time we have to run it. Okay. So when process P naught was executing, it was at the zero. Definitely there was no processes waiting. That is why it executed till 3 unit of time. Okay. During this 3 unit of time, here we can see two more have been arrived in the queue, that is P2 and P3, right? But out of P2 and P3, why did we take P3? The reason is not because it is coming fast, because it is looking with the priority. When P3 and P2 were in the queue, the priorities of P3 is 3 and priority of P2 is 6. Which is on the lesser side? Priority 3 is on the lesser side. So they will give you in the problem statement, lesser the number, less the number, higher the priority. If this is given, then 3 is having the higher priority. If in the problem statement they have given higher the number, higher the priority, then 6 will be on the higher priority. So when now P2 and P3 are in the ready queue, which one you should give the preference? Definitely who is having the less priority. That is 3 is the number, lesser number, but it is having the higher priority over that. So after P3 has been executed, P3 executes for till what time? Till 7 unit of time. If you see till 7 unit of time, all the remaining processes are in the queue. Which are the remaining processes? P2, P4, P6, P5 and P7. Now we have to check what is the priority of P2, what is the priority of P4, what is the priority of P6 and what is the priority of P7 and P5. If you look this 1, 2, 3, 4 and 5, out of this, the priority of P2 is what? 6. Priority of P4 is 5. Priority of P5 is 7. P6 is 4 and P7 is 10. Which is less among this? Definitely this one. 4 is lesser among 6, 5, 7, 10. Right? So that is why the next process which will be running is P6. You can see here P6 is the next process which will be taking. So this will be deleted from the queue, right? So what is the process time of P6? P6 process time is how much? 4. So it will be running 7 plus 4 is 11. Till the 11 unit of time, that is process P6 will be running. Okay. Now, once the P6 has been completed its execution, once again you check in the queue. P2, P4, P5 and P7 are remaining. Okay. Out of P2, P4, P5, P7, which is that process which is having the higher priority, right? So this has completed its execution now. Remaining is P2, P4, P5 and P7. Looking at P2, it is having 6, P4 is having 5, P5 is having 7 and P7 is having 10. So the next process which will be running is definitely P4 because it is having the number 5 which is lesser than 6, 7 and 10. So this is taken as the higher priority and this will be started with the execution. So P4 takes the control of the CPU and it starts executing. And what is the process time of P4? It is 2. So 11 plus 2 is till 13 unit of time, it starts its execution. So this is how the giant chart has been drawn. Okay, so once P2 completes its execution, remove it from the queue. The remaining is P4, P5 and P7. Look at P4. P4 is, sorry, P4 has completed its execution, right? So remaining is what? P2, P5 and P7. P2 is having 6, P5 is having 7 and P7 is having 10. So out of 7, 6 and 10, out of 7, 6 and 10, the priority which is having the less number, 6 is lesser. So lesser the number, higher the priority, right? So which is lesser? 6 is lesser. So which is the next process which will be running? It is P2. Next will be running P5 and next it will be running P7. So this is how we are drawing the giant chart. Okay. So once the giant chart is ready, definitely we can easily calculate the completion time. What is the completion of time P1? It is 3, P3 is 7, P6 is 11, P4 is 13, P2 is 18, P5 is 27 and P7 is 37. That is how we have calculated here the completion time. Seeing the giant chart, we can easily calculate this completion time. Okay. So now coming to your turnaround time, how to calculate the turnaround time? It's quite easy. That turnaround time, the formula to calculate your turnaround time is completion time minus your arrival time, right? Turnaround time is equals to completion time minus arrival time. So 3 minus 0 is 3. 18 minus 2 is 16. 7 minus 1 is 6. Similarly, we calculate the completion time, turnaround time for everything else. And what about waiting time? Waiting time is equals to turnaround time minus, you can see here, turnaround time minus burst time. Okay. Turnaround time minus burst time. Okay. So waiting time, how to calculate waiting time now? Turnaround time, what is the turnaround time of P1? 3. What is the burst time of P1? 3. 3 minus 3 is 0. Correct. So P2, what is the turnaround time of P2? It is 16. What is the burst time of P2? It is 5. 16 minus 5 is 11. Correct. So turnaround time of P3 is 6 and the burst time of P3 is 4. 6 minus 4 is 2. So this is how you will be calculating the rest of the waiting time. So the question might be asked, calculate your average turnaround time and average waiting time. So how to calculate this? Sum of all turnaround times divided by 7 and sum of all waiting times divided by 7. You will be getting the average turnaround time and average waiting time. Okay, so this is how you will be calculating the average turnaround time and average waiting time. So response time, it is very rarely asked in your exams, but response time is when the process starts its execution. Okay, so process P1, if you see the giant chart over here, when it has started the execution at the 0th unit. Process P2, look at this. Process P2 has started the execution at 13 unit of time. Process P3 has started the execution at 3rd unit of time. Okay, so seeing this giant chart, you can easily calculate the response time. Response time is nothing but when a process starts its execution. Starts its execution is what is your response time. Okay, so that can be easily calculated by seeing this giant chart. Okay, hope so. The points are clear. So we will be seeing the next algorithm in the next video. Till then, thank you.